Here's our first part for copper recovery cycle. To start, we take our copper turnings and then weigh out around 0.5 grams of copper turnings. We just need to record the full mass to the nearest milligram. I can now take this, go to my hood, and prepare for the next part. For copper recovery cycle, I have my pre-weighed copper right here. I need to take and cut my copper turnings into smaller shavings in order to help speed up the reaction. So I'm just going to go and cut small bits into my weigh boat very carefully. I do not want to use too much force because it will send the copper flying out into the hood. Now that I have my copper cut into smaller pieces, I will make sure that my area around where I cut is clean to regather any lost shavings, and then I can begin the next part of copper recovery. Here's our first step for copper recovery cycle. I have my pre-weighed copper turnings, about 0.533 grams, and then I have 10 milliliters of 6 molar nitric acid pre-measured into my 10 mil graduated cylinder. I have my 250 ml beaker on top of a hot plate here, so I can take my copper and then my 10 molar nitric acid, and then I can begin gently heating the solution. I do not want the solution to boil, so I'm only setting my hot plate to about 70 to 80 degrees Celsius. We are working in a hood because we are performing an oxidation reduction reaction on our copper turnings. We are going to be oxidizing the copper and reducing the nitrogen from the nitric acid. So we will be producing nitric oxide, which is a brown toxic gas, and we will be waiting for copper to go into solution. So I can wait here until my copper fully dissolves. We will be able to see it since the solution will be clear and it will become a greenish color. Once we've reached that stage, I will take my distilled water and fill my beaker about halfway full with distilled water. As you can see, we are starting to have the blue copper complex form in the water, showing that we are having our reaction with nitrogen start. And I can start to see the brown nitric oxide gas coming off of our copper. You can clearly see our reaction is going very quickly now. We are getting plenty of brown gas forming inside of our beaker. The liquid all the way around the bottom of the beaker, you see, has turned blue, showing that our copper is dissolving and entering the nitric acid. We're down to just a few small turnings left, so we will only need to wait a little longer in order to have copper fully dissolved into solution. Now my copper has completely dissolved, so I can go ahead and now fill my beaker with distilled water about halfway full. Note that our solution is a bluish-greenish color, as we would expect. And now as I add the water, it is becoming much more blue. I can turn the heat off of my stir plate, and now I have my copper solution ready to go for my next step in the copper recovery cycle. Next up, we are on to our second step in the copper recovery cycle. Here I have my beaker of water that was on my hot plate. This has my copper solution inside of it. I need to take it and remove it from the hot plate now. Now that it is off my hot plate, I can now add 30 milliliters of 3 molar sodium hydroxide. I have it pre-measured in my 100 ml graduated cylinder. And as you see, our light blue solution has turned into a very deep blue. So we can tell that this is a precipitation reaction because you can see a solid has now formed all in our beaker, making it very cloudy, and it has changed the color of our solution. So this is our precipitation reaction for our second step in the copper recovery cycle. Now we are on to our third step in the copper recovery cycle. I have here my solution that has my precipitate in it from step 2. I now need to take it, add it back to my hot plate. I need to add 10 glass beads first, so I can take and pour several beads out into my weigh boat. I now have my 10 glass beads that I need in my weigh boat. I can now take and add my beads to my solution, and now I can begin to gently heat my solution to its boiling point, and I need to be stirring the solution gently the entire time. I do not want to rapidly boil the solution. I only want to get it up to its boiling point. The moment it has reached its boiling point, I will remove it from the hot plate. As you can see, our solution has turned significantly black as we've heated it. However, we keep stirring until we can see that there is no longer any color remaining and there is just our black precipitate left in solution. As of now, I am no longer seeing any green color in my solution. So since I have no longer any green in solution, I should have decomposed all of my copper into copper oxide and water. Here I have my solution of copper oxide that is decomposed. Since it is done, I can now set it onto my benchtop to cool, remove my stir bar. Once it is cool, I can move on to the next step. Here is our solution that contains our copper oxide precipitate. As you can see, as it's cooling, the copper oxide is settling to the bottom, but you can notice along the rim up here just above the water and even in the water still, it is cloudy because there is some copper oxide that is not settled. We want to be very careful as we perform these next steps to gather all of the copper oxide, that way we do not lose any of it or minimal in these next steps. It took us about 10 minutes to have the copper oxide almost completely settled to the bottom. Now we are going to decant into a 400 ml plastic beaker. We want to be very careful when decanting, to go very slowly, to just remove our liquid and not disturb the solid that we have settled on the bottom. As you can see, I am only very gradually pouring out the liquid. I am not trying to quickly dump all the water out. Now I need to let my solution settle again so that the solid sits back on the bottom. It slowly gets disturbed as we decant off. This time I only need to wait about a minute or two just to get the solid to settle down. This step in the process is likely where you are to lose a significant amount of copper if you do not perform the step very carefully. This is why we are taking extra time to just allow our solution to settle. Be very cautious. We want to try to retain as much copper as possible. We have decanted off about as much liquid as we can. So now I'm going to add about 200 mils of very hot water into my beaker. Now I will need to let it settle again, and I will come back and decant once more. Now that our solution has settled again, I can decant once more, just as before, very slowly decanting off the top layer of water. Set the beaker back down and let it settle once more. Then we will finish by decanting as much as possible off of our copper oxide. Here's our fourth step in our copper recovery cycle. We have our now settled and decanted copper oxide in our beaker. I'm going to be taking and adding 15 mils of 6 molar sulfuric acid into our solution. I have 5 mils pre-measured in my 10 mil grad cylinder. As you can see, our solution is now going back to blue. It is removing the black copper oxide. This shows that we are performing a neutralization reaction using our sulfuric acid. We are now having a solution of copper sulfate and water form. I am taking and rolling my beaker to grab all the copper oxide that was sitting on the lip of our beaker. This will allow us to retain as much copper as possible in our process, because we have likely lost some here and there throughout our steps. Now I can take my metal tweezers, remove my glass beads, and place them into my used glass beads container. I pulled all 10 of my beads out of solution. I can go ahead and swirl one last time to make sure all the copper oxide is dissolved, and then I can move on to my next step. Now we are moving on to our final step in the copper recovery cycle. In this step, I'll be taking and adding 10 to 12 drops of hydrochloric acid, 6 molar, and I'm going to be adding in some cut aluminum foil. I have cut it myself from the aluminum foil that I have been provided. So our first step is to add our drops of hydrochloric acid. Now I will take my stir bar and I will add in some aluminum foil. As you can see, our aluminum foil is breaking apart in our solution, and our solution is becoming cloudy. This is again another oxidation reduction reaction. Our copper sulfate is being reduced, and our aluminum is being oxidized. Once this reaction is over, we should be left with our copper solid collected in our beaker and some aluminum oxide in our solution. Observing my solution now that it's settled, I can see that it is a murky gray. There does not appear to be any blue color left in solution. This should mean that I am done with the reaction and I do not need to add any more aluminum. Here we have pre-weighed our evaporating dish for when we need to recover our copper with it. As you can see, it is 28.756 grams. We will record this, and then when we gather our copper into it and dry it, we will be able to tell how much copper we have remaining. Now that we have allowed our solution to settle, you can see that it is not necessarily colorless, but it is the murky gray, which means that we are done with this reaction. Our copper has settled, so I can take and decant the solution into my beaker here. Now with this decanting step done, I can take and add 20 mils of water. I will then decant off this water, and I will repeat this decanting process 2 more times. For our final step, we will take our copper and transfer it into our pre-weighed 50 ml evaporating dish, and then this will go on our steam bath to dry our copper, and then we can find out the mass of copper we have remaining.
Now you see my beaker is clean. I used spatula and transferred all copper that was in the beaker into the pre-weighed evaporating dish. So everything is here now. And I will put this dish on a steam bath to get rid of any traces of water, methanol and acetone. So now I'm putting my evaporating dish with copper inside to a steam bath to get rid of any traces of water, methanol and acetone. And I need to heat it for approximately 5 minutes to make sure that my copper is dry. Now, after about 5 minutes of heating, I will take the evaporation dish from the steam bath and put it to cool. And now my dish is cool. I need to make sure that I dry the bottom of the dish. And this is our first reading of our copper. It includes the weight of copper and the weight of evaporating dish, and it's 29.270. Now we will take this weighboard and put it on steam one more time, let it cool and weigh it one more time. So we will be waiting until the weight stabilizes. So once again we are heating the second time our dish with copper in it. We'll heat it for about 5 minutes and then wait one more time, and we will repeat doing this until our weight stabilizes. So this is our second reading of the mass, and it is 29.269. This is our third reading of mass, and it's 29.269. So it's exactly the same that it was the second time. So the mass stopped changing. Don't forget that this mass includes the mass of copper and the mass of the dish. And when we subtract the dish mass from this mass, we will find that the copper mass is 0.512. We started with the mass of copper 0.533 gram. So actually we recovered 96% of our copper.